Hey everybody, so we're back. We're going to do some examples and I'm going to use the number line to do these things. The properties of addition are going to become just something we do by rote when we start combining like terms. But we need to go back and do some harder problems on our number line about signed numbers. And I can talk about how we use the properties of addition. We could change it up, but we don't have to. The thing is, those are tools, okay? They are tools that you desperately need in solving equations. And they're truths. It's not just that they're tools, they're truths. The properties of addition, I didn't make them up. No mathematician made them up. No teacher made them up. No philosopher made them up. They are. Okay? If I hand you 2 Oreo cookies and then I hand you 3 more, you had 5 Oreo cookies. If on a different day I handed you 1 Oreo cookie and then, 3 Oreo cookies and then 2 back, you still have 5. It doesn't matter the order. Okay, so I have 2 examples. Just 2. We're going to do upside down, okay, we're going to use our number line. -3 plus 6 minus 7 is... So let's number line this up because I want to make sure that until you get the mental journey of like being able to do this, you can have a visual journey, okay? Period. I've been doing this forever. And if I don't know how other people think. I think how I think. So when I've had examples that people have used that I have found important and helpful, I've tried to incorporate them. Okay, again, I am creating eternity right here. You're welcome. I'm going to put 0, positive numbers, negative numbers. Start here. So, let's give some dashes so we know. Now, I really wish I had more. Gotta go brave the COVID to get more colors right now. So, these dashes don't have to be perfect. We're on an ideascape. Okay? I remember being a child and going up to my teacher and saying, this length says 5 inches and this length says 4, but the one that says 4 looks longer. It is longer. And my teacher was like, just go by the numbers. I remember this moment. It's the only time in my life that I asked a teacher a question during a test. True story. Because I was really upset about it. I had my ruler out and everything. So I've tried to make it evenly spaced, but it's not going to be perfect. All right, so let's go on our journey. This is a sentence. It's a math sentence. Negative. So I'm starting here. And this tells me to go that way, right? So here I am. 1, 2, 3. That's where I am. Right here. All right? We're on a road trip, our mathematical road trip. Now, this tells me what? Next step. Plus. That means I'm going that direction. How many? 6. Count it out, baby. 1, 2, 3, 4, 5, 6. Where am I? We count from 0. 1, 2, 3. I'm at positive 3 now. Now, many of you guys realize because of the commutative property, see, my brain always switch up. You can flop these. 6 minus 3 is 3. We memorize that, don't we? 6 take away 3. But not everybody gets it when the negative comes first. Okay, so now we're at 3. Here's where we are. Journey. This tells me to go that way, right? How far do I go that way? I go 7. Well, I just went 6. Maybe some of you already get this, but we're going to count it out. 1, 2, 3, 4, 5, 6, 7. Well, where am I? I'm at -4. Right? I'm in this direction, 4 units. 1, 2, 3, 4. I'm 1 unit away from where I was at -3, where I started. Now, some of you might realize I can do this first. And because you might even know the absolute value idea, and because 7 is 1 greater than 6, its absolute value is 1 greater, that means that this comparison is going to make it 1 more negative. So then you just do that. 3 and 1 is 4. But that you don't have to. We can just go on our little journey. Okay? I say to students all the time, there are shortcuts. I want you to build the pathways in your brain of the cuts. And I will try to show it to you, all right? But there is always the long way. Always. Always. It's like, I might have a route to get from my house to yours. Okay? And my route is the roads that are the roads that I know. You might tell me, oh, you took that road? Oh, you know what? If you took this is a shorter route. Well, because now I'm getting your knowledge, right? But it doesn't mean I still can't find your house. I can find your house. It just takes me a little longer. It's not the fastest route. But it doesn't mean it's not a route. So over the years, I've seen a lot of people, a lot of students, judge themselves for not finding the fastest route. And peers do it to each other all the time. You didn't get this. First of all, if you're a kid who does that, that's rude and mean. Stop it. Second of all, everyone's on their own journey, so leave them alone. This is the road. All right, let's do another example, but I have 4 numbers this time. Look at the magic of that. And you think this is low technology. It's high. It's high tech. Okay. Number line. Example 2. Total math teacher problem. All right. Again, if nothing is written in the front, that is implied to be a positive number. Okay? There are several implications in math. Most of them are lean on positive. 0, 1. I'll explain those as we go. Like, there are a lot of zeros and ones floating around here with operations that we just don't write because it'd be way confusing. Like the identity that we just talked about. Okay, so we start here. I'm going to cozy up with my whiteboard. Start here. We're going how many units? 12. Implied, there's nothing written here. Implied positive. We're back to the Ladybug Picnic. So I'm going to sing it, okay? It's for Gen X. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And they all came around for the Ladybug Picnic. All right, I'm way over here. Way over at 12. Awesome. What does this tell me to do? It's a negative. Can you see it? Can you see it? It's a negative. What is it telling me to do? It's telling me to go back this way. How many units? 6. From here, right? 1, 2, 3, 4, 5, 6. I went -6. I'm going to write that up there so I know that's the journey I took. So now I'm here. I'm going to tell you right now, as long as you can figure out your spaces, it actually doesn't matter that you calculate where this is. I mean, this is +6, but you don't have to as long as you make a mark and you're still on your journey and you recognize where you are in your code, right? This is like coding. So now this tells me to go this way 2 more units. 1, 2. Now I'm here, wherever that is. And again, this is 4, but I don't have to necessarily know that. Now this tells me to go that way. How many units? 4 units. So let's hope I didn't make too much of a mess of my slashes. 1, 2, 3, 4. I am right here. Well, how far am I from 0? I'm going to count now from 0. 1, 2, 3, 4, 5, 6, 7, 8. 8 in the positive direction. I am at 8. Now, if you want to use the commutative and associative properties, you could say 6 and 2 is -8. 12 minus 8 is 4. 4 plus 4 is 8. Okay? You can absolutely do that. You could have added these. 12 and 4 is 16 and added those. 16 minus 8 is 8. We're going to land on 8 no matter what. No matter what. We could totally change this order and I could start -6, -2, and then bad back. I will always end up at 8. Always. Because that's how these relate to each other. Always. Because this owns the phantom plus, this owns the negative, that owns the negative, and that owns the positive. Okay? They just do, so it shifts that way. All right, shoot, I'm at 10 minutes. All right. Stay safe, everyone. Happy math. Coming up next, we are going to start to really get into order of operations. Okay? So I'm going to introduce what multiplication is, what it even is, and we'll go from there. Okay, we're going to still deal, just so you know going forward, we're going to still deal with the realm of integers. If you don't remember what that is, you can look it up. You can go back to the video. Integers are what we might call positive and negative whole numbers. Okay, they're whole. They're not fractions. They're not decimals. There's no fractional part. Okay, see ya.